Why is PLC ladder logic debugging so challenging? Have you ever wondered why debugging Programmable Logic Controller ladder logic can feel like searching for a needle in a haystack? Let's break down the reasons behind this challenge. First, ladder logic is designed to resemble traditional relay logic schematics. This graphical format is great for simple tasks, but as programs grow, it can become overwhelming. Large ladder logic programs often have many interconnected rungs and branches. This complexity makes it tough to trace signal flow and understand the overall logic sequence. When things go wrong, identifying the source of faults can be quite tricky. Another factor is the sequential nature of ladder logic execution. The program runs from the top to the bottom, rung by rung. This can lead to timing issues or race conditions that aren't obvious during debugging. To troubleshoot effectively, you need to monitor the timing and state of inputs, outputs, and internal memory bits. This requires careful observation and interpretation. Moreover, debugging involves both software and hardware components. Programmable logic controllers control physical devices and sensors. Therefore, faults may stem from programming errors or issues like wiring problems, sensor failures, or unexpected conditions in the field. This interplay complicates the process of isolating the root cause of problems. Additionally, debugging often takes place in live industrial environments. Stopping the process can be costly or even unsafe. This limits the ability to conduct extensive testing or simulation. Engineers often relying on specialized debugging tools, such as watch tables that show real-time variable states and breakpoints that pause execution at specific points. While these tools can help visualize data flow and logic execution, they require skill to use effectively. From an electrical engineering standpoint, debugging ladder logic demands a solid grasp of control system principles and Boolean algebra. Engineers must interpret how ladder logic translates into real-world control actions and how faults in the logic impact the entire system. In practical applications, such as manufacturing automation or robotics, effective debugging is essential. Errors in programmable logic controller programs can lead to equipment damage, production losses, or even hazardous situations. Therefore, thorough testing and debugging are vital before deployment. So, the challenges of debugging Programmable Logic Controller ladder logic stem from the complexity of the programs, the sequential execution model, the integration of software and hardware faults, and the constraints of live environments. Understanding these factors can help engineers tackle the debugging process more effectively.